Hi, welcome back. So we're continuing on with our Unit 3 review, and we're going to move on to this triangle here where it wants me to find each measure. Okay, and I do kind of have a lot going on here, so I'm going to take it little bit at little bit. Okay, so first of all, the first thing I see is the only numbers I have is I have a 51 here, I have a 110 here, and I have a 60 here. So I know my vertical angles are going to be equal. So if this one's 60, A also has to be 60 because they are vertical angles. So they have to be exactly congruent. Okay? When I look at B, let's see if we can figure out B. I don't know if we can do these in order, but we'll see if we can. Okay? When I look at B, B is part of this corner, but it's also part of this whole line here. If I just cover up that much, I can see I have a line. And I know on each side of a line, I have 180 degrees. So if I've used 51 degrees and 110 degrees, I've used 161 degrees. There's 180 degrees on one side of a line. It's really bright. There we go. 180 minus the 161 is 19 degrees. So that tells me that angle B is 19 degrees. Okay? And the reason I know that is because the angles on one side of a line add to 180 degrees. Notice I didn't say the angles on one side of a line are supplementary because supplementary is strictly used for pairs of angles, and here I have more like a trio of angles, but they still do make 180 degrees. Okay? Alright, so next if I want to look at angle C is inside this triangle here. And I know that the three angles inside a triangle have to add up to 180 degrees. So if I've used 60 and I've used 19, I can figure out what is left for angle C using my triangle sum theorem, right? So I'm going to add my 60 plus my 19, which is 79 degrees, and I have a total of 180 degrees, which leaves me 101 degree for angle C. And to find that out, I used the triangle sum theorem. Okay? Now for angle D, I have two different ways that I can find angle D. Okay? For angle D, I can think of it as an exterior angle. If I cover up this part of the picture, okay, angle D is an exterior angle to this triangle, which means I could just add the 60 and the 19 together, which we've already done here. 60 plus 19 is 79. So I would already know this was 79 degrees using the exterior angle theorem. But if I didn't remember the exterior angle theorem, once I found this angle here using my triangle sum theorem, I also know that on one side of a line, those two angles are a linear pair, so the angles on one side of a line add up to 180. So if this is 101, I could just take that away from 180 and also get my 79 degrees. So I could use the exterior angle theorem, or if I don't remember that theorem, I can use the idea of a linear pair. Okay? All right, so now angle E. Let's look at angle E. To find angle E, angle E is inside this triangle, the smaller triangle here, the right side triangle. And I know the three angles. The angle sum theorem says the three angles have to add up to 180. I've already used 79 degrees and 51 degrees. So if I take 79 degrees plus 51 degrees, That leaves me with 130 degrees used for these two angles. If I take that away from 180, that means I have 50 left for angle E. And that was using my triangle sum theorem. Okay. Last but not least for this problem, we have angle F. And angle F is asking me for this exterior angle out here. And I know the exterior angle is equal to the sum of the two remote adjacent interior angles, 79 plus 51, which we've already added together. So I already know it's 130 degrees without even having to do any more work using my exterior angles theorem. Again, if I forgot my exterior angle theorem, I would just have to remember that these two together are a linear pair. So if I've used 50 degrees here, when I take that away from 180, it leaves me with 130 degrees. So I could also use my linear pair theorem, just like on letter D. Okay? All right, let's look at number 5 real quick. Number 5, given triangle ABC is congruent to triangle DEF, find the value of y. So I'm going to look and see, I've got x's and y's in here, it's just asking me for y. So y is here on DE, so I need to know what does that correspond to. Using my corresponding parts, I know they're going to be in congruent triangles, and they're going to be congruent. So DE is my first two letters, so I know it matches up with AB. So those are my corresponding parts. They're in congruent triangles, so I know they are equal. My 5y plus 3 is equal to 10. I'm going to subtract 3 on both sides, and I'm going to get 5y equals 7. Divide both sides by 5. And y equals, I can either leave that as 7/5, or I could change it to a decimal, which would be 1.4. Okay? But I don't want to make it a mixed number. We rarely ever want to use mixed numbers in a mathematics class. We like to use mixed numbers when we're driving places like 1.5 miles, or when we're baking something like 2 2/3 cups, but we never want to use mixed numbers when we're working in a math class. We always want to either leave it as a fraction, or if it makes a nice, what we call a terminating decimal, so it's not irrational that keeps going on and on forever, then we can change it into a decimal. But either one right here, either 7/5 or 1.4. Okay? All right, so that's the first half of the Unit 3 portion. So we just have 5 more questions to work on in the next video. All right, thank you so much for watching.